Who the math? Who the math? Who the math? Who the math?
Plus, sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise. Teachers, have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can...
Hello, welcome to video 18, More Mad, and Intro to Standard Deviation. This is Mr. Miller, and right here is Mr. Lewis.
That is me. All right, today we're going to move past MAD and go kind of just briefly into standard deviation. More to come tomorrow.
We're going to get past our anger, huh?
Yes.
All right. So here's a set of data we're actually going to use throughout the whole video. So it's just some data items here. And the vertical line there, could you label it, Mr. Lewis, as X bar? That's the mean, so not the median. We're using the mean now. And we want to know which measures of spread are used with the mean. And there are two. First one is the MAD statistic. And the second one, standard deviation. All right, so kind of like yesterday's video, we're looking at how far the data points are from the mean.
Right.
So how do you calculate the deviation?
Well, the deviation is you take the data point. So, for example, if we take 90 here, and we subtract that from our mean, which is 100. So here we had 90 minus 100. It's a negative 10 deviation.
Yeah, in yesterday's video, we just talked about the distance from the point to the line. That's okay, because that's what we needed for the MAD statistic. But today we're showing a little bit more detail. The numbers to the left of the mean are negative, because they're lower than the mean. The numbers to the right of the data points to the right of the mean have positive deviations. And if a value is right on the mean, like this one down here, we can't forget that one, that has a 0 deviation. So we have to include that in our calculation also.
Exactly.
So deviations can be positive and negative. Okay, let's hit the next slide.
All right.
So there's the graph again with the deviations. We're going to go through the same table as last time, just showing you a little bit more detail. We have the mean, the deviation, and then the absolute deviation, the absolute value of it.
Okay.
So this is a little bit different than last time.
So here we have the mean, which we can calculate by our 5 numbers, but Mr. Miller was so nice to already give us here in our chart.
Look at that. I couldn't resist.
We know all these are 100, so I'm going to get lazy. I'm just going to draw a line straight down. Okay.
Okay. And then yesterday we just filled a column called the absolute deviation. That's okay, but we're showing a little bit more detail today.
Right. So here I want to figure out each deviation. So again, they're already listed up here. So 90 was negative 10. 92 was 92? I think that's a typo from the 98.
Ooh, make that a 98.
Yeah. Okay, 98. So this one was negative 2.
Yeah.
100 was 0. This one was 2. This one was positive 10.
Could you put an X bar symbol above the mean so we get used to the symbol?
Of course.
And then the deviation would be X minus X bar. X represents a data value. So all this formula is saying is take the data value, subtract the mean. That's how we got that column. And then this one would be the absolute value of that. So yes, we just said the difference between the numbers, which is correct, but we're being, like I said, a little bit more detailed today. Absolute value of negative 10 is 10.
Negative 2 is 2. 0, 0. These are already positive, so we just left them
So
back down.
this isn't anything different. We're just emphasizing the absolute value part of the absolute deviation.
Right. And Mr. Miller, why do we want to make it so that we have the absolute value and not just add up these?
Because what do you get when you add those up?
Well, looks like I get 0.
That's true. So that's not very helpful. For every data set, if you just add up the deviations, you get 0.
Right.
So if every data set, you get the same thing, 0, that's not describing the spread very well.
No.
But when we make them positive, and the easiest way is to take the absolute value, then they all count. And we add them up and divide by how many. So let's go ahead and find the MAD for this.
Okay, so if we add these up, here we have 12 and 12. That's 24 divided by our total of 5.
4.8.
4.8.
So that's the MAD. Okay.
All right.
All right.
So what's the other way we could find a positive number?
Are you ready for this?
I am.
All right, here it goes. You asked for it. The standard deviation.
Yeah.
Wow. Okay. This is a big event.
It is. So our mean still is 100.
And that value is still 98.
Yeah. So Yeah, all right, I'm going to get lazy again. All right.
Okay,
98.
we're gonna find the deviations again. So
Okay,
same
this
as the
one,
MAD, we just
negative
subtract,
10.
take the data value, subtract the mean. Those are the same, but we're gonna make them positive a different way.
Right. This time we're going to square it. Okay, so instead of our absolute value, we're going to do x minus x bar squared.
Let's go ahead and fill these in. The mean is
Okay.
x bar. The deviation is x minus x bar. And this means we're going to square it.
Correct.
Okay, negative 10 squared is?
100.
Very good. It's not negative 100.
No,
So
it is not.
remember,
Yeah,
when you
we
square a
should-
negative, you should get a positive.
Right.
All right, and then negative 2 squared is?
4,
Then that's 0.
0, 4, 100.
So it's just a different way of making them positive. And we're going to take kind of an average. That's what this first symbol at the bottom is. But instead of dividing by how many, we're going to divide by the number of data items minus 1. So Mr. Lewis, when you add those up, you get 208.
Okay, 208.
We're going to divide that by 4.
4.
And we'll get into later why.
This is 5 minus 1.
Right, so I know there are 5 data values, but we're going to divide by 1 less. And there's a reason for that. And 208 divided by 4
52.
is 52. Now, that would be great, but we squared the data. So we want some way of kind of unsquaring it. How can we unsquare it?
Well, I think when you unsquare, we take this funny little symbol called a square root.
Very good. So to kind of undo the squares, that's because we want the spread to have the same unit as the data. So to kind of undo the squares, you take the square root. And so the square root is square root of 52.
It's got to be 7 point something.
7.2.
7.2.
Okay. So Mr. Lewis, one more time. How does this compare to the MAD?
Well, we compare it to the MAD. It's very similar with the deviations, but instead of taking the absolute value, we square it. They both measure the spread of our data away from the mean. All right? So we square them up instead of taking the absolute value. And then we find the, like Mr. Miller said, it's almost kind of like the average, but we go under 4 and take the square root, which gives us our standard deviation.
Yeah, so the ending is a little bit more complicated than math. But standard deviation is far more useful.
Right.
And that's what we're going to use most of the time.
And there are these funny looking symbols. Remember the sigma here? That means the sum of. In math, we're lazy. We don't like to write sum of. So that just means you add up the whole column.
Yeah, so let's add up the squares and then divide by n minus 1 and then the square root of all of them.
Right.
Very good. Okay.
Man, journal time already.
I know, that was quick today. So we have a couple conceptual questions for you. So you're going to have to think about this. For the first one, come up with 4 data values that have a mean equal to 20 and a MAD equal to 0. Okay, so think about that a little bit. What would they have to be?
I don't know.
And then question number 2.
Question number 2 would be 2 numbers have a mean of 10 and then a MAD equal to 2. So we want to know what could those numbers be.
And number 3 is just to drive you crazy. Is there more than one answer to number 2? So if you come up with an answer number 2, just think about it. Could you have done it a different way?
Yeah.
All
Sounds
right.
good.
We'll see you in class.
All right.